but I can do that on my screen as well. So, no worries. So sometime in life happens. Yeah, we'll have a screen here. So, hi everyone, at last. I'm so happy being with you today. And for those of you that you don't know me, I'm Theodore. I'm a software engineer. I'm working on a project called Proxima Analytics. We're doing ethical, privacy-first analytics. So you can definitely check this out. I'm also based in Athens. And every single time that I want to make a talk, I'm trying to tell a story. So again, today I'm going to tell you a story. So our story starts back in 2021. And it was summer, hot summer in Greece. So one day I woke up in the morning, and I actually couldn't breathe. I could smell like something burned inside the house. And there was like a huge fire in the outskirts of Athens. It burned like an area as big as Cluj-Napoca. And this lady you can see over there, that's a photo that has been taken and it made it to the time cover. This is her house burning, and she had to evacuate the house that she actually spent her entire life. And this again and again happened in 2022, 2023, and so on. And the reason I'm so excited with you today and giving this talk for the very first time is because I feel deeply connected with Romania in so many different ways. Every single time we were in need, Romanian firefighters were the first ones to come and help us, working tirelessly day and night with our Greek colleagues. And if by any chance you have your phones on your hands, like now, because as I was studying this topic, I found out that Romania is the #1 country for illegal timbering. So I'm not saying to do so, but if you have your phones on your hands, and by chance there's like a huge QR code in the background, this is a documentary about a Swedish company producing crappy furniture and meatballs, and actually illegally harvesting your forests. Yeah, I could tell so. And because I wanted to make something, I had to study how wildfires are actually working. So they're part of some ecosystems, like the Mediterranean one. They can spread really quickly, up to 20 kilometers per hour. Based on the weather conditions. They are actually, when they hit a critical point, they're unstoppable. You may have seen the wildfires, the mega fires in California, Siberia, Australia, and so on. Their sources are actually unpredictable, so they can be a spark from a motorbike chain, a piece of glass, a cigarette butt, farmer's chores, beekeeper's chores, and so on. So it's crucial to actually take action as fast as possible. And in order to do so, because I have a hobby of tweaking electronics on and off, I had this idea that maybe we can actually bring a device. And before we start up, we have to set up some goals, right? So we want our device to be affordable, obviously, easy to deploy, as accessible as possible, and obviously open source as well. And for those of you that you have no idea about hardware, today I'm your guy. So I'm not sure if you're familiar with a piece of technology called microcontrollers. So they're like actually small microchips that come into a shape of a board. So you may have heard like Arduinos, Raspberry Pis. In this particular case, we're going to use ESP32, which is like a microchip, really popular and affordable as well. And in order to program our board, like creating a prototype, we have a few options out there. The first one is like a superset of C or C++, so we can write C, flash the firmware, and we're basically done. But there are also a few options out there. So for example, we have Python. Adafruit, an industry leader in the IoT space, they have developed a framework, if I can say so, called CircuitPython. And in the Node.js ecosystem, we also have a few options out there. And this is a JavaScript conference, obviously, so we're going to talk about JavaScript. So you might be wondering why on earth we want to write JavaScript on an on an IoT device. And the reason is that JavaScript is event-driven by design, and most of the times you have to handle events. So the device itself, the board, it's like bare bones, but you can connect external modules like a button or an LED or a sensor. So you have to tackle events all the freaking time. You can take advantage of the NPM registry. So if there's a package there, you can actually use it. There's a thing that intrigues me the most, which is about bridging technologies or mix and matching technologies. So you can actually have JavaScript in the microcontroller, and then you can have a React Native application interacting with the Bluetooth API and so on. You can use a JS server all around, like building stuff all together using the same language over and over again. And there are a few options out there. There's like Cylon, Nodebots, Johnny5, which actually work as a proxy, so you can directly connect the controller into your working station and send commands to that. There's also another interesting project called Spruino, which actually is a compiler, so you write JavaScript, translate it into bytecode. But today we're going to focus on a fresh project, if I can say so, which is called DeviceScript. So DeviceScript is developed by Microsoft Research Labs. It allows you to write type-safe code. It allows you to target different boards, and that's amazing, actually, because you can run the same code over different hardware specifications. It has lots of core libraries and APIs. It runs inside VS Code along with Platform I/O, which is a standard for IoT development. And it also provides simulation and testing. So if you have like a circuit, you can actually simulate everything inside your browser or your VS Code, run it virtually, and when you're ready, just transfer it into your breadboard. And for those of you that you have actually skipped your physics class, I'm your guy again. So here we are. This is a live feed directly from my browser. I think that's why we had problems along the process. So here we have a battery. Here is a button. Here is an LED, and here is a buzzer. And obviously, as you would expect, there's no current flowing inside. If we press the button, we have a flashlight and a sound, right? So basically, this is the hello world of IoT development. Just to give you a perspective now, this is the board itself. As you can see, it's like super tiny. It barely fits on my finger. So the board itself has it has pins along the side. So we can directly connect this setup into our board. And in order to do so, we can use the DeviceScript core libraries. So we have, first things first, all the pins are labeled with D. The pins starting with D, they're like digital inputs or outputs. So we can allocate the bulb, or the LED, on pin D3. We can allocate the button on pin D10, and then we can subscribe to events, like pure JavaScript, pure type-safe JavaScript. And once the button gets pressed, well, we toggle on and off the LED. Pretty straightforward. But you might be thinking, how on earth are we going to move from like a single button LED up to something like detecting wildfires, right? So basically, every single component that comes alongside the board, it's translating physical signals or events into voltage. So for example, the button, as we press the button, the current flows. So we have a voltage change. Similarly, we have some different options out there, like sensors that work with different polymers, with different materials, and so on. And because we want our board to be like as versatile as possible, we have actually developed temperature and humidity sensing. So we can deploy the board and grab environmental data. In order to do so, we're going to use a microchip, again, a sensor, if I can say so, which is called AHT20, and it has built-in support for DeviceScript. Once again, we can import the core library, the core API, and actually schedule grabbing values, and then we can send them into a web server or storing them somewhere, and so on. Once again, we will have like the sensor over here. I'm not sure if you can see that. Like, it's extremely tiny over here. And I was talking about like bridging technology. So as you can see, we have a live feed directly from the sensor to the browser. That's the web serial API, so nothing included. And this is the live feed. So if I can start like tweaking a bit, it might be a bit stuck, but yeah, it doesn't work. That's the live demo as always. But if you want to actually, can I check something? Yeah, it works. So if we want to move on then, we can attach two more sensors. So we have a gas and a flame sensor. The gas sensor detects gas concentration, so we can detect carbon monoxide, carbon dioxide, as well as different gases, and we can find out if there is a flame. The flame sensor works with a small component called photodiode, which actually interacts with infrared light. So we can directly include the library again. We can set up a threshold for the gas concentration, and if there is something in place where every 5 seconds we're going to check if there's a flame, and then raise an alert. So just to give you another perspective, let me bring this along here. Yep. So this is the flame sensor over here. This is the photodiode over here. So obviously, I have a light demo that I want to demonstrate something. I'm not sure if it's going to work, but the idea is that I don't want to produce smoke inside the area, right? Because we have smoke detectors on the ceiling. But the smoke sensor actually works with different gases. So ideally, I have lighter here, so I could try and trigger the thing, and maybe it should work. The demo gods love me, right? So I'm sorry if I jump scare you or something. There are like 5 different devices spread across the room. It's for you, actually. You can take them home. They're actually designed and manufactured for this event specifically. So take them home. They have instructions on top of them and a power bank as well. So you can start your IoT world, essentially. Yeah, sure. And the reason we have like devices spread along is because we want to cover a huge area. So we're using a framework called, more or less, a protocol, if you can say so, called Painless Mesh. So the microchip we're using it has built-in Wi-Fi and Bluetooth capabilities. And the idea is that we can actually spread them and cover as much area as possible. And then, using the protocol, we have a mesh network. And because we do have a mesh network, if like a device goes poof, the network is self-healing, so it can keep working. We can broadcast messages. This is what I did here. So I broadcast a message to every single device in the room. We can directly set inbound and outbound messages, and also doing, they're called over-the-air updates to the firmware. At the edges of the network, we have our gateways, basically the very same device, but we can connect them to a Wi-Fi network if there is available. We're talking about off-grid applications, right? We can use a GSM module, so we can have 3G or 4G communication, as well as a protocol called Swarm, which is actually a satellite communication protocol based on our needs. And eventually, from this type of thing, like jumper wires are all over the place, sensors, boards. Can you imagine the fun flying with that and passing the airport security? So eventually, we can bring something together. If you have a chance to take a glimpse on the devices, this is basically a full prototype board. So once we have everything in place, we can attach a battery and a solar panel and actually deploy it out in the wild. Everything can get squeezed from the breadboard into a single board. We have 3D printed cases just to protect the circuits inside. And there is a thing. We already have deployed a small cluster in a metropolitan forest in Athens. But there is a thing that the development cycle is really slow because we have to actually tweak designs on the hardware spec, send for manufacturing, and all over again. And we want to get an SC certification in order to provide out in the wild. Just, you can follow me around and keep you posted on that topic. So there's more, though. There's always more, right? So effectively, we can work along with a framework called LoRa. So LoRa, it's like a communication protocol, low energy. We can achieve like communication, off-the-grid communication up to 30 kilometers. So we can create like something like a WAN, local networks of clusters that they can communicate each other. And also, if you're interested in that topic, there's a really amazing project called Mestatic. So you can get a device that costs around 15 euros, up to 20 or something. And you can provide peer-to-peer, off-the-grid communication, and create your own networks and so on. Really, really amazing community. Effectively, if we have a setup like this one, we can also provide like post-apocalyptic communications or something like for ground units and stuff like that, hitchhikers, you name it. And obviously, it's the AI era, so I want to be one of the cool kids. As I was trying to explore different options out there, I found out Prophet, which is a framework. It's based on R. It's built by Meta. So basically, because we have the devices out exposed to harsh weather, rains, sun, so on, electronics fail, as you may know. Prophet allows us to forecast when a sensor is going to die or it's going to need maintenance. And I was shocked because I found out that this is a standard in the chemical industry, for example, for the past 30 years. But we're using, as soon as some of the devices deployed out there starts failing or needs maintenance and so on, we will have the data and move on. And next up, there's tiny machine learning. The board has just 8 megabytes of flash RAM, like super tiny. But there are cool applications out there, and TinyML is one of them. So basically, if you have a sensor, you have metrics out there, you can train your own models and deploy them into the device. There is a really interesting sensor that I'm experimenting right now. It's called BME 688. Like, they can work on the name a little bit. It's developed by Bosch. So it's a gas sensor, ultra sensitive. It comes along with software that's called Bosch Studio. As you can see there, it can detect smells. So in this video, they're training the actual device to detect coffee based on air. And it intrigues me a lot because we're experimenting with the idea that we can effectively detect smoke more precisely. And we can do more. We can detect the entire life cycle of a forest. We can detect when pollinators are coming in place, or wildlife passes through the forest, or gases from decomposing leaves are exposed to the air. Like, lots of opportunities out there. And here's the big question. Like, we have so much data out there. Can you actually somehow predict when and where a next wildfire is going to happen, maybe? And the answer is actually yes and no, because we have like really big data there. There's Copernicus, which is the AU environmental monitoring system that has data for wildfires, climate change, satellite photos, and so on. Data population density data. We have maps, so we can track down highways, because this is where most of the starting points for wildfires happening, based on sparks, glasses, cigarettes, you name it. But there is a problem, because right now there are like different studies. There's a great one from California, but we cannot yet correlate all that data. But as far as we're gathering money to expand our network of devices and so on, I think we will get there. There's a cool thing that we're trying to deploy right now, which is basically once a fire happens, we can actually extend the device. We can have a one direction sensor and an anemometer, if this is how it's called. So we can directly predict how the fire is going to spread. And we can create like dead ends for the fire not to spread into cities or destroy as much as it can. And I want to wrap like really quickly everything, because I I know everyone's like quite tired. But I want to try something different. So there's a chance every time I'm attending a conference, I'm like super hyped and super impressed by people getting into stage and like providing or exposing a whole new idea. And I told you, I'd like to tell you stories most of the times. So I had that thing where I want my talks to have like intriguing titles, and I have that song stuck into my head. You may have heard it. It's like, the roof is on fire. Yeah, maybe, yeah. And it hit me like, it's not about listening to someone telling you, hey, I made that cool stuff, which is whatsoever. It's about the opportunity. Like, we're in North Romania, gathered together, like 500 people, all driven by the same thing. Like, it happens through that we're writing the same language, right? And we're making a living based on some common base. And I want to, if you want to, like, spend some time and think about that. Like, 15 years ago, someone would, if you would tell someone that I'm a JavaScript engineer, like popping alert boxes in browsers or something, and today you can say, hey, you know what? From my office, I can design something, run JavaScript on that, send for manufacturing and deploy it on field and make a living, like actual hardware. Something that was like a privilege for big companies for a very long time. This is big, actually. So I want every single one of you just to take some time, appreciate the person standing next to you, enjoy your time in the conference, and up until the next one, I want to thank you so much for your time and patience. Yeah, that's it.